This video will give you information on solubility and saturation. As you know, on the back of your periodic table, some salts are soluble, some salts are insoluble, and some salts are limited in solubility, also known as slightly soluble. There is a mathematical basis for these solubility labelings, and I want to talk about that today. A salt is soluble in water if more than 1 gram of that salt can be dissolved in 100 milliliters of water. Every soluble salt has a different limit, as in maybe it can do a lot more than 1 gram, maybe it can do 1 gram, but generally anything that is over or equal to 1 gram dissolving in 100 milliliters is considered soluble. A salt is insoluble if less than 0.1 gram can be dissolved in 100 milliliters of water. Insoluble salts don't mean that 0 grams of the salt dissolves, but anything less than 0.1. So it's very, 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 very small amounts of it dissolve in water. Thus, it is labeled insoluble. So the final category is the in-between. What about in between 0.1 and 1 grams? This is known as limited or slightly soluble. This is when 0.1 to 1 gram of that salt can be dissolved. Every salt that is limited in solubility will have a different number. And so I'm going to show you a little bit of an example with calcium hydroxide. Calcium hydroxide is limitedly soluble in water, and its solubility is 0.19 grams in 100 milliliters. The temperature is important because as you increase or decrease temperature, the solubility will change, but we're going to keep everything at 20 degrees Celsius and not worry about the change in temperature. When the limit of solubility is reached, any additional calcium hydroxide that you add will remain undissolved. It will sink down to the bottom as a solid. And that is true for any limited soluble salt. Once it reaches its solubility limit, it will produce a solid. This phenomenon is known as saturation. A solution is saturated when it has dissolved as much of the salt as possible. The saturation point for various salts will differ depending upon its solubility. So a really highly soluble salt like sodium chloride will have a large amount that you can dissolve in water, and so the saturation point will be higher than something that has lower solubility. We can do mathematics with this number. We're going to do that in scenario A. Suppose you have a beaker containing 75 milliliters of distilled water. A scoop of calcium hydroxide is added to the water and stirred until no more salt dissolves. That means the limit of solubility has been reached. When saturation has been reached, there's some leftover salt and the amount is 0.24 grams. How much water must be added to dissolve the rest of the undissolved salt? 0.24 grams. So first I'm going to start by sketching a picture. Here's my beaker. Got some water in it. I've got calcium dissolved, some amount, and then at the bottom I've got undissolved solid. And my beaker is full to 75 milliliters. Question's asking, you have to add more water. How much to dissolve that? We can set this up as a proportion. The original recipe 0.19 grams of calcium hydroxide over 100 milliliters is equal to 0.24 grams over X milliliters. Cross multiply and divide and you'll end up with 127 milliliters. This is how much you have to add to dissolve the rest of the salt. If all the water in the beaker is evaporated, what mass of solid calcium hydroxide will be present? Well, we know that the original amount that was left over was 0.24 grams, and we need to find out how much was dissolved in the solution. So again, we can set up a proportion, 0.19 grams of calcium hydroxide over 100 milliliters is equal to some amount of calcium hydroxide over 75 milliliters. If you cross multiply and divide, The amount that was dissolved in solution was 0.143 grams. That makes sense because the limit of solubility here is 0.19 for 100 milliliters. This sample had 75 milliliters, so this number should be less than 0.19, which it is. Then to get the full answer, you add them together for a total amount of salt dumped in. So this is the scoop. The scoop was made of 0.383 grams calcium hydroxide. Last question. Suppose you have a beaker containing 150 milliliters of distilled water and a scoop of calcium hydroxide added until all the powder dissolves. How many grams of calcium hydroxide were in the scoop that was added to the water? This should be answered with an inequality, and you'll see why. We set this up as a proportion, again using our known value, 0.19 grams of calcium hydroxide dissolves in 100 milliliters. Set that equal to x grams over 150 milliliters. And the amount is 0.285 grams. This is the maximum amount of calcium hydroxide that you could add to 150 milliliters and dissolve all of the solid. However, it doesn't have to be that much. So this is where an inequality is useful. Less than or equal to. The person added less than or equal to 0.25 grams. The main point that I want you to gather from this is this idea of limited solubility, that you could have a salt that produces a little bit of solid, and that could be a limitedly soluble salt. And that's indicated as a question mark on the back of your periodic table on the solubility table. So that's something to keep in mind moving forward.